Right, so we are in section 4.2, which is called Integer Representations and Algorithms. So we're going to work with number bases. So we've seen a binary, converting from binary, from decimal to binary, from binary to decimal. We're kind of going to expand that arithmetic a little bit to other number bases, specifically octal, base 8, and hexadecimal, base 16, and in general also, okay? So this is kind of, we're revisiting some stuff, but also kind of adding a bunch more number theory that has to do with modulo to this, right? So if b is an integer greater than 1, then if n is any positive integer, it can be expressed uniquely in this form. Okay, so basically this is a base b expansion of an integer n. So this says that I can take any positive integer n and write it as a sum of powers of this base b. So the a are the coefficients and the b is the base to different powers. Okay, so these a0, a1, and ak are non-integers less than the base b, with ak, so the first one is less than, is not equal to 0. This is called the base b expansion of n, and it's written as this. Okay, so basically those coefficients, by multiplying the bases to different powers, you write them from left to right, and that gives you the base expansion. Okay, so let's look at something familiar. All right, so what is the decimal expansion of the integer that has this as its binary expansion? Okay, so basically we want to change it to this form. So I'm looking for a number n. These right here are these coefficients. They're these a's. They're going to multiply different powers of 2. Okay, so if I work backwards, because this first, the number on the right goes with 2 to the 0, right? And then as you increment, they're going to increase powers. Okay, so this is 2 to the 0 to the 1, to the 2, to the 3, to the 4, 25, to the 6, to the 7. Okay, so this means it's 1 times 2 to the 7 plus 0 times 2 to the 6 plus 1 times 2 to the 5 plus 0 times 2 to the 4, 1 times 2 to the 3, 1 times 2 to the 2, 1 times 2 to the 1, and 1 times 2 to the 0. So again, so this base 2 expansion, the 1s and 0s are numbers that are less than b, less than the base 2, and the order matters. So each of these numbers are coefficients that multiply the different powers of the base. So basically I'm using this. I plugged into that. Okay, so now we calculate. We can see that the one with 0 coefficients will go away, and the one with 1 coefficients get calculated. Okay, so 2 to the 7 is 128, and 2 to the 5 is 32, and then an 8, and a 4, and a 2, and a 1. If we add them up, we get something good. All right, so all this right here gives me 15, and this gives me 160, so added together I get 175. So that's in base 10. That's the base 10 version of this binary expansion. All right, cool. Let's look at another example. So a second example, what is the decimal expansion of the number with octal expansion 7016? Okay, so now we're sort of doing the same thing, but using base 8. All right, so we have our number. It's going to, these are my a's, these are my coefficients. So 7 times 8 to the power, so this 6 right here belongs to the power 0. So I count 0 and 1 and 2 and 3. Okay. So the first power is 1 less than how many digits you have. So if you have 4 digits, it starts with power 3. And then the 0 goes in front of a to the power 2, 1, 8 to the power 1, and 6 times a to the power 0. All right, so let's calculate this. So this will vanish. And then I have 7 times 8 to the 3, which is 512. Then plus 8 plus 6. So 7 times 512 plus 8 plus 6 gives me 3598. Okay, so that's the answer in base 10. Okay. Okay, so this is an example with a hexadecimal number. Okay, so hexadecimal numbers have 16. That means base 16. So your digits are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But that's only 10 of them. So you start using letters. A, B, C, D, E, F. So A stands for 10, B is 11, C is 12, D is 13, E is 14, and F is 15. So basically you have 16 digits / characters in your vocabulary. All right, so let's look at 2AE 0B. Okay, and this is base 16, and we want to expand this. Okay. So 2 is a coefficient that multiplies 16 to the, let's see, 1, 2, 3, 4, 5 digits, so the first power is 4. Then we have A, which is 10 times 16 to the 3. We have E, which is 14 times 16 to the 2. 0 times 16 to the 1. And B is 11 times 16 to the 0. Okay. Of course, out anything with coefficients of 0, and then we do the math. Okay, like at this point, you can just sort of plug things in your calculator. So 2 times 16 to the 4th power. Where is my power? That's a big number. Did I do that right? I think 16 to the 4th power is a big number. Yeah. Times 2 plus 10 times 16 to the 3 plus 14 times 16 squared plus 11, right? So I got 175,627. Okay, so that's the base 10 expansion. The base 10 answer. Right, hexadecimals are useful in computing. You might have seen them in a color palette. So like I'm using Photoshop right now. So if I want to pick colors, you can see like the colors I pick have a certain code, and you basically see letters. Right? So this is a hexadecimal code for this color. So they're very common in doing computer work. Okay, so the previous examples we converted from a non-decimal base to a base 10, but now we're going to look at the algorithm that converts from base 10 to other bases. Okay. So this gives the steps, but basically I will demonstrate by doing the example. Basically, this is repeated division and keeping track of the remainders. Okay, so again, we sort of saw this with base 2, but we're doing this in other bases now. So I'm going to take the number 1, 2, 3, 4, 5, which is a base 10 number, and find the octal expansion. Okay, so I want to write my numbers like this. All right, so that's kind of the division algorithm. So n is the quotient times the divisor plus the remainder. Okay, so, and basically the remainders, the mods put together, will give you the expansion in that certain base. So I need to take 1, 2, 3, 4, 5 and divide by 8. So kind of repeated division by 8. So it's going to be 1, 5, 4, 3 times 8, and then the remainder 12, 3, 4, 5 minus 1543 times 8. This gives me a remainder of 1. All right, and we repeat this until this turns into 0. So now we're going to take this 1543 and divide this by 8. And I get 192 plus the remainder. So 1543 minus 192 times 8, remainder of 7. I'm going to take this number and divide it by 8. So 192 divided by 8 gives me 24. So this is 24 times 8. It's exact, so I get a remainder of 0. I take 24. And this is 3 times 8 with the remainder of 0. And then I take the 3. And this goes 0 times 8 plus a remainder of 3. So you need to make that into 0. So don't stop before you get that to 0, otherwise you're going to miss a digit. Okay? Now your expansion goes from bottom to up. Okay, so your octal expansion is 3, 0, 0, 7, 1, base 8. So make sure that you go backwards, bottom to top. All right? And you can check that by doing the reverse. So if I take this and I do 3 times 8 to the power 1, 2, 3, 4, 5, 4, 0 to 8 to the power 3, 0, 8 to the power 2, 7, 8 times 8 to the power 1, and 1 times 8 to the power 0. Hopefully you get 1, 2, 3, 4, 5. Let's do a quick check there just to make sure. So 3 times 8 to the power 4 plus 7 times 8 plus 1. Yes, so indeed, okay, it checked out. Okay? All right, you don't have to do the check unless you want to kind of be extra super sure. All right, let's do another. Okay, so this example says that I want to change this base 10 number, 177130, into the hexadecimal expansion. So now we're going to do repeated division by 16, okay? And then write it as, we want to write the number as, right, the base, whatever I'm dividing by, times the quotient plus the remainder. Okay, so that's, I'm using that format. So 177130 divided by 16 gives me 11070 times 16, and then a remainder of 177130 minus 70 times 16, a remainder of 10. Right, then we keep doing this. 11070, divide that by 16. We get 691 times 16. Let's find the remainder. 11070 minus 691 plus times 16 gives me a remainder of 14. Keep doing it. 691 divided by 16. 43 times 16. And the remainder is 3. Take 43 divided by 16. And we get 2 times 16 with a remainder of 11. And then finally take 2, and that's going to be 0 times 16 plus a remainder of 2. Okay, so bottom to top 2, and my 11 is a B, then a 3, my 14 is the E, and my 10 is the A. That's the number in base 16. Cool. All right, and just for kicks, let's do a binary expansion. So I want to take 241 and find the binary expansion. So we're going to keep dividing by 2. Okay, so 241 divided by 2. Get 120 times 2 with the remainder of 1. And 120 divided by 2 is 60. All right, 60 times 2, the remainder of 0. Then 60 is 30 times 2 with the remainder of 0. 30 is 15 times 2 with the remainder of 0. 15 is 7 times 2 with the remainder of 1. 7 is 3 times 2 with the remainder of 1. 3 is 1 times 2 with the remainder of 1. And 1 is 0 times 2 with the remainder of 1. Okay? So again, bottom to top, I'm going to have 1, 2, 3, 4 ones, 3 zeros, and a 1. Okay, so that's the binary expansion of that number. All right.